We wish to find the average rate of change of a function over a particular interval. So here's the problem. Find the average rate of change of f of x equaling x squared minus 3x over the interval 1, 4. Now, we define the average rate of change over an interval AB to be f of b minus f of a all over b minus a. So for us, our interval AB is the interval 1, 4. So for this particular problem, f average is f of 4 minus f of 1 all over 4 minus 1. So we need to evaluate f of 4. So we put that into the function. That's 4 squared minus 3 times 4. That turns out to be 4. And f of 1 is going to be 1 squared minus 3 times 1. That's negative 2. So f average turns out to be 4 minus a negative 2 divided by 4 minus 1. So 4 minus negative 2 is 6, divided by 4 minus 1 is 3. So the average rate of change of this function over that interval is 2. Next problem. Find the slope of the curve f of x equal to x cubed minus 2x at the point 2, 4. So in order to find the slope of the curve at this point, we need to find the secant slope first. So let's find the secant slope. So the secant slope says, let's look at the change in y over the change in x. So we're evaluating the slope at 2 different points. That is f at x plus h minus f of x all over the change, which is x plus h minus x. So this gives us f at x plus h minus f of x all over h. So we need to first compute what is f of x plus h. F of x plus h says find x plus h cubed minus 2 times x plus h. x plus h cubed is x cubed plus 3x squared h plus 3x h squared plus h cubed. So that's x plus h cubed. And then we're going to subtract off 2 times x plus h. So that gives us minus 2 minus 2h. Okay, so now we're ready to find the secant slope. So the secant slope turns out to be our f of x plus h is x cubed plus 3x squared h plus 3x h squared plus h cubed minus 2x minus 2h. And then we have to subtract off f of x, which is x cubed minus 2x. And this whole thing is over h. So our secant slope becomes, well, let's see. Looks to me like this x cubed and this x cubed are going to add to 0. And this negative 2x, and this negative, which makes positive 2x, will also add to 0. So now we're going to end up with 3x squared h plus 3x h squared plus h cubed minus 2h, the entire thing, all over h. We want to factor out the h, so we're going to have h times 3x squared plus 3x h plus h squared minus 2, and that whole quantity is over h. And now we can see that these h's divide and give us 1. So we're going to have 3x squared plus 3xh plus h squared minus 2. So this is our secant slope. Now, we know that in order to figure out what our actual tangent line is, we look at the secant slope as, so we're going to take our secant slope and that's the difference where we use x plus h and x. And we're going to let h get really, really small. So we're going to let h go to 0 in order to get our tangent slope. So from our secant slope, we have 3x squared plus 3xh plus h squared minus 2. And again, if we let h go to 0, then we end up with 3x squared minus 2. So now we know our tangent slope. So the slope of the tangent line which in many contexts we use m, is a function of x, and it is 3x squared minus 2. So we were asked to find the slope of the tangent line at the point 2, 4. So therefore, at the point 2, 4, we get m is equal to 3 times 2 squared minus 2, which is 10. Lastly, if you're asked to find the equation of the tangent line, We have a point. And we have a slope. So the equation of the tangent line using the point slope form would be y minus 4 is equal to 10 times x minus 2.